TRiFLEX-C is a project supported by LIST and funded by MasterXR, which is part of the EU Horizon Europe Research and Innovations Programme. TRiFLEX-C proposes an immersive extended reality educational application that enables anyone, engineers, researchers, interns, and PhD students, regardless of expertise, to safely learn and practice cobot programming without hands-on risk. It allows users to solve the lack of expertise required to program robotic arm for microfiber manipulation. The main objectives are recognize safe zone around a robot and program basic collaborative robot tasks related to microfiber operations.
Traditionally, operators manually load delicate microfibers into a specialized specimen holder for different testing, as fragmentation, for instance. However, this manual process presents several challenges, including damaging the sample, the risk of sample misalignment, and occupational health concerns, such as eye strain and hand fatigue caused by repetitive sample preparation tasks. At least we are addressing this challenge by automating the process using robotic arm, equipped with a piezoelectric gripper and smart linear stages. As a researcher and educator in the field of material science, I find the extended reality educational scenario proposed by TRiFLEX-C highly innovative. It enables users to learn how to operate this robotic system, which includes a robotic arm, a piezoelectric gripper, and a smart linear stage, in a safe, intuitive, and engaging manner without requiring prior knowledge of robotics.
As an engineer and PhD student specializing in microfiber science, I found the XR educational application both interesting and easy to use for microfiber manipulation. I appreciated several features like the motion preview before execution, the real-time visualization of the laboratory environment using live camera streams, and the ability to control the whole real system, including the 3D microstages and the piezoelectric gripper with a unified interface.
The system incorporates safety zones, which are very useful for learning and understanding safety procedures. It also includes a virtual assistant that guides trainees throughout the learning process. In addition, the application supports collaborative learning, allowing multiple users to participate and learn together whenever the educational scenario requires it.
We evaluated two training methods for robotic manipulation in microfiber operations, one computer-based and one using extended reality. We conducted a user study to investigate learning preferences and training effectiveness. The results provide important insights into how these two approaches can complement each other.